F5, sliding down an incline and hauling a mass up. So what we're going to do now is look at this situation where this mass here, M1, is going to go down, and M2 is going to go up. And there's mu here. So in this problem, we're going to let the kinetic coefficient just be mu so we can write down less. Now you might ask, didn't we just do this problem? Well, actually we didn't. We did the problem where the M2 was pulling down. And when you go this way, then the friction goes in a different direction. You have different equations, you have a different problem. So the answer is no, we really didn't do this problem. We have to do it again here with the new frictional force, going the other way. So if we go ahead and set this up down as positive, here's normal force. Now the tension and the friction are working, they always work against you. If you're moving down, friction is going to be opposite, always opposite. So here if we go M1G, there's theta. Remember that the angle theta here, if you want, you can go ahead and indicate this theta, and both of these angles are complementary to that angle there, so therefore they are equal. And then the second mass, T going up, M2G going down, and here up is positive. And just to emphasize here, going down is positive. And then the equations here would be M1G sine of theta minus T minus F is M1A. Go ahead and do this one while we're at it. T going up minus M2G is M2A. And then here for the normal, you got N minus M1G cosine of theta equals 0. And the auxiliary equation, the friction is mu, and where we know that mu is a kinetic coefficient. And now we're ready for the solution. So we have our sketch. Remember the 4 steps as guide. Sketch, and then here, force diagram, or the free body diagram, and then 3, the equations, Newton's second law, and then 4, solve, or the solution. And my strategy is to always work from the bottom up. So I use the friction and the normal equation to get mu M1G cosine of theta, since the N is mg cosine theta, first mass. And then when I plug that in for N there, I get mu M1G cosine theta. Then I like to go with this friction, plug it in to the top equation. So I have M1G sine of theta minus T minus the mu M1G cosine of theta equals M1A. And then I like to go to this equation, which has the T in the opposite fashion, and add the equations together. So if we do that, we'll have M1G sine of theta minus M2G, the T's cancel, and that's going to be equal to the sum of the masses on the right-hand side times A, because we're adding M1 plus M2, each are hitting the A. Basically finished here, because now we just simply divide by the sum of the masses, and we have it. Here I'll go ahead and pull the G out. So I'll have M1. See, we missed something here. Hold it, we missed something. We missed this piece in here. We add these equations together. We have the M1G sine theta, the M2G, I forgot this one. So there's also here a minus mu M1G cosine of theta. So now on this left-hand side, see, I'm going to divide by the sum of the masses. On the left-hand side, I'm going to pull out here the G. So I'll have M1 times, M1 is going to be multiplying sine of theta, and minus mu cosine of theta, like that. And then we're going to have the minus M2 by itself, like that, over the sum. And we're going to have a G in there. So we got a lot of stuff here. Let's go ahead and make that a parentheses, and then we'll make this a bracket and put the G on there. So everything is accounted for now. See, it's very easy to miss something, so it's always good to check your work, go back, and see if everything's looking good. So that's the acceleration. Now I realize we're doing lots of problems here without numbers. That's more challenging. So you're getting a good workout in this chapter with all these symbols. Even if you have numbers, you can plug the numbers in last, say. So this is a good technique to learn, to be comfortable working with the symbols. So now to find the T, this looks like the easiest equation right up in there. So T is equal to M2A plus M2G, and then the A has to go in there. So we got some algebra here to do, and this is going to equal, we'll go ahead and have here M1 times M2. When the M2 hits that M1, you're going to have the product, and that's going to be sine of theta minus mu cosine of theta. And then when that M2 hits over that second term, you get then the minus M2 squared. That's all over N1 plus M2 times G, and then we're going to have plus M2G. So this is similar to what we did before with the other case. And now we want to multiply here top and bottom by the sum so that I can combine the terms. All right, so when we do that, we'll have everything over M1 plus M2. Up here we'll have M1, M2, sine of theta, minus mu cosine of theta, minus M2 squared. And then here I'll have M1, M2. I'll put the M1 first, and then we'll have the M2 squared. And there's going to be a G outside. So this is nice. See, this is going to cancel this. And then we're going to get something similar to what we had before. We're going to have the product of the masses. And then we're going to have here 1 plus this stuff in here, the sine of theta minus mu cosine of theta, all that over the sum. And that's going to be hitting the G from here. So that's it. So these are the two equations. We have this one for the tension, and we have this one for the acceleration. Do the dimensions check, masses cancel here with G, good. Here you have an extra mass in the numerator and a G, mg, these are dimensionless. Yep, that's a force. So that looks good. So if we want to do a quick check, we can look at the case where we had the two hanging masses. We go back to here, we had the two hanging masses. And now, so if we redid this problem where M1 is the big mass, then we have to swap these. So we would have, for example, here, and that would be M1. So in other words, if we called M1 the big M and went this way, we would have this equation where you would have M1 minus M2 over M1 plus M2 times G. And here, this is nice, this equation is basically the same, 2M1 M2 over the sum times G. That has to be correct, because if this is the positive direction going down this way, in this case, and M1 is bigger, then that checks out. That's how you can adapt the equations for the new situation. Or you can quickly retrace your steps and redo the problem. It wouldn't take that long. All right, now let's see what happens here. If we go to the 90 degrees, this is a 1, this is zip, and you get M1 minus M2 over the sum, check. You get it. And here, if you go 90 degrees, you got a 1 and a 0. 1 plus 1 is 2, and you get this, check. Now, a question you might ask is there a shortcut? So can you get these equations from the other problem that we did, F4? The answer is yes. And in the textbook, I explain how you can do that.